Alright guys, welcome to this page of the notes. What we're going to do here is we're going to take the trig functions that we just talked about and their ratios, the ratio of the sides of the right triangle, to write the trig functions for the acute angles in the example problems I've got for you here. Before we go ahead and get started, just to sort of help us remember, because we just learned it, so let's go ahead and write our little memory trick. It is SOHCAHTOA. That's an A. Alright, so there's SOHCAHTOA. Again, that's just to help me remember sine is opposite over hypotenuse. Let me close my O. There we go. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Hopefully that'll help us remember as we go down through these. And then of course what we're going to do is we're going to look at both acute angles in the triangles. Please notice I want you to do sine, cosine, and tangent for R. There's R. Then I want you to do sine, cosine, and tangent for S. There's S. We can write the trig ratios for both acute angles. Every right triangle has two acute angles. We're going to do them both. So first, let's start with S. I'm sorry, R. All right. There's angle R. There's angle R. So let's go ahead and write our trig functions for R. First, sine of R. Well, sine is opposite over hypotenuse. If this is R, opposite is across from the angle, so that's 4. Hypotenuse is the longest side, that's 5. So 4 over 5. Cosine. Well, cosine is adjacent over hypotenuse. Well, if this is angle R, the adjacent side would be 3. Again, the hypotenuse is the longest side, so 3 over 5. And then tangent, our good old friend tangent, we talked about in the last lesson, opposite over adjacent. Here's R, opposite is 4, adjacent side is 3, 4 over 3. Okay, well I still have another acute angle. There it is right there, angle S. Angle S. So let's go and do sine, cosine, and tangent for angle S. The sine of angle S. Well again, sine, opposite over hypotenuse, so the opposite side is now 3. The hypotenuse is still the longest side, 5. So sine is 3 over 5. Okay, cosine. Cosine S. Well, cosine is adjacent over hypotenuse. Here's angle S. The adjacent side is right next to it, 4. Hypotenuse is still the longest side, that's 5. So 4 over 5. And tangent. Again, tangent opposite over adjacent. Here's S, opposite is 3, adjacent is 4, 3 over 4. And there you go. You've written all three trig functions, sine, cosine, and tangent, for both acute angles in this right triangle, right? You just find the angle, and then knowing the ratio, you got to know the appropriate ratio, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. As long as you know those ratios and you found the angle, you can just write then those trig ratios. Let's try another one. Here we go. J first. Here's J. All right, here we go. Let's do sine. Sine of J, well, again, sine is opposite over hypotenuse. If this is J, opposite, hypotenuse is the longest side, so 5 over 13. Cosine of J, well, cosine is adjacent over hypotenuse. Here's J, so the adjacent side would be 12. The hypotenuse is the longest side, 13, so 12 over 13. And tangent, J, opposite over adjacent. Opposite over adjacent, 5 over 12. Now, of course, we could then go ahead and do the exact same thing for the other acute angle K, but I do want to point out something to you here. I mentioned it for tangent in the last set of videos, the last set of notes. You'll notice that the tangent functions for the acute angles are just inverses of each other. Tangent S, 3 over 4. Tangent r, 4 over 3. It just flips, right? Wouldn't it be nice if cosine and sine did the same thing? They don't, but they still do something that's really very interesting. Please notice that sine s is 3 over 5. But when I do cosine of r, 3 over 5, right? So these guys are the same ratio, just for different angles. This is the sine of s, this is the cosine of r. Same ratio, right? I'm just talking about two different angles. Same thing happens for this one. Cosine of s, angle s, is 4 over 5. But when I go to angle r, it's then the sine of r. That's 4 over 5. So essentially, here's what happened. When you go from one acute angle to the other acute angle, the cosine and sine ratios switch places. Well, let's see if that helps us out down here. If that's the case, then that would mean, since sine of j, right, what would be the sine of k? Well, the sine of k would be whatever cosine of j was, in this case, 12 over 13. Check it, check it. We know that sine needs to be the opposite over hypotenuse. Opposite, 12, hypotenuse, it works. What about cosine? Well, cosine is going of k will be whatever the sine of the other one was. Well, sine of j was 5 over 13, so cosine k has got to be 5 over 13. Check it, see if it works. Here's my angle. I know cosine is adjacent over hypotenuse. Adjacent, 5, hypotenuse, 13, 5 over 13. And the tangent's the easy one. Just flip them. Tangent k equals 12 over 5. Okay, hopefully at this point you are getting more and more comfortable with writing these ratios. At this point you may even now have those ratios memorized. So here we go. We'll quickly run through these next ones. Here's L. Sine of L, opposite over hypotenuse, 8 over 17. Cosine of L. Cosine is adjacent over hypotenuse, so 15 over 17. Tangent of L, opposite over adjacent, 8 over 15. And then we go ahead and write the ones for N, but I'm just do the easy part where they just switch places. So sine of N will be whatever the cosine was, 15 over 17. The cosine of N will be whatever the sine of L was, so 8 over 17. And the tangent just flips. Sorry, not L, tangent of N. And that'll be 15 over 8. Okay, so again, please use SOHCAHTOA to help you remember what the ratio is. Do not mix up the ratios. You will not get the right answer. And just practice, practice, practice. Taking a look at a right triangle, writing the trig functions for both of the acute angles, doing the proper ratios, either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Head on over to the next page of the notes and we'll actually take a look at solving some problems using these trig functions. I'll meet you guys there.